Hello, students. As I mentioned to you yesterday, there are not many notes with this week's topic. And today, we're going to finish up our notes. Normally, during this topic, we do a lot of laboratory activities dealing with both the single replacement reactions and the double replacement reactions. Of course, under the current circumstances, we'll be watching videos of those reactions. But nonetheless, we're going to finish up our notes here today. And so before we get into our notes, quick review from yesterday. We talked about Zeus and Harry and Clarice. And perhaps you remember that love triangle that existed between those three individuals yesterday, and what kind of chemistry existed between those three. Does anyone remember? What type of chemical reaction did they illustrate? Single replacement reactions. That's right. Zeus replaced Harry. And that was the end of the story. But we've got another story today. So fear not, ladies and gentlemen, as we continue with our fourth and final type of chemical reaction for today, which is double replacement reactions. That's right. Double replacement reactions. So what in the world is a double replacement reaction? Well, let me tell you. A double replacement reaction is one in which two compounds. Now remember, a compound is made of two or more elements. Two compounds react to form two new compounds. So there's not just a single replacement that's going on in a double replacement reaction, but rather, well, there is a double replacement going on because there's going to be something from each compound that are going to replace one another. So let's check it out here. Let's get to our notes and first write the general format of a double replacement reaction. Again, these are variables, not element symbols. We've got AX, which is representing a compound, two or more elements bound together. And we've got BY, again, representing a compound of two or more elements. So we start off in the reaction side of the equation with these two reactants, AX and BY. Now, because this is a double replacement reaction, notice what's happening. The first letter, the first variable of each compound are replacing one another. Now, I want to add some information to this that you should pay attention to because it will help you in identifying double replacement reactions as well as single replacement reactions for that matter from yesterday. And that is when, if you think back to when we first started learning about chemistry, we talked about some standard notation or ways in which to write things. And when we write formulas, the metal is always written first, and the non-metal or non-metals are written second. Keep that standard in mind here, because if we've got two compounds with two or more elements, what do you think the first element is? What kind of element? A metal or a non-metal? Yeah, it's going to be a metal. So here's the deal with double replacement reactions. When we've got two compounds, it is the two metals that are replacing one another. The nonmetals are left alone. When we go from the reactants to the product side of the equation, it is the metals that replace one another. And so in this general format, check it out. The X and the Y, the nonmetals, stay where they are, and it is the metals, the A and the B, that switch locations. So we start off with AX, we end up with BX. We start off with BY, we end up with AY. And again, remember that these are variables, not symbols, but they apply as a general format to all double replacement reactions. So let's see if I can give an effective analogy for double replacement reactions. Love. Love is in the air. Boom, 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 boom. Love is in the air. All right, so here we have young love. We've got, and I know you're just loving these analogies. We've got two different couples. We've got a couple on the left that are both blue-eyed individual, blue-eyed boy and a blue-eyed girl. And over on the right-hand side, we've got another couple, but this is a brown-eyed boy and a brown-eyed girl. Ooh, a brown-eyed girl. Do, 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 do. All right, it's an old song from the 50s. Anyway, so we've got two couples, the blue-eyed couple and the brown-eyed couple. And they seem happy together. But one day, they go to a party and they see one another from a distance. La, 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 la. And the fireworks start to happen. Oh my. Check it out. The blue-eyed boy and the blue-eyed girl look at the other boy's partner and says, ooh la la, my heart's a thumping. I want to dance with that other girl. And so guess what happens? They're at the party, and it is the boys. It's always the boys, right? The boys go head to head at it and start fighting one another, or maybe we could think of it a little bit more friendly and just ask nicely to butt in and dance with the other boy's partner. And so that's what they do. So now we have the brown-eyed boy with the blue-eyed girl and the blue-eyed boy with the brown-eyed girl. And again, they look rather happy and content. So hopefully that is a good story of just, school dance, and they're just dancing with other people. All right. Hopefully there were no real fireworks going off, and hopefully no fighting taking place. But you never know at a school dance. So here, this analogy hopefully illustrates. Oh, here's another example. There used to be a TV show on called Wife Swap. Have any of you ever heard of that show? If you have heard of the show, then I think you can probably tell how that fits into this analogy as well. If you haven't heard of the show, I'm not going to waste your time. So let's get to the example here in terms of chemistry. Again, double replacement reaction. The general format, the two metals replace one another. And remember where metals on the periodic table are located, over on the left-hand side of the periodic table. Here's a great example of a double replacement reaction. And it illustrates sodium bicarbonate being added to acetic acid. Sodium bicarbonate and acetic acid. Do you know what those two things are? Baking soda and vinegar. This is something you could do at home. I'm sure you have some vinegar and baking soda around. You could put some baking soda into a little container and add some vinegar to it and watch what happens. And chemically, what is happening is this. Notice the first letter, the first symbol, the first element in each compound, sodium and hydrogen, located on the left side of the periodic table. They're both metals. This is a double replacement reaction. So notice what happens to the sodium and the hydrogen as they go from the reactant side of the equation to the product side of the equation. Do you see what's happening? Check it out. The sodium replaces the hydrogen, and the hydrogen replaces the sodium. So over on the product side of the equation, the C2H3O2 no longer has the H in front of it, it has the sodium in front of it. This is called sodium acetate. And likewise, the HCO3 no longer has sodium in front of it, has another hydrogen in front of it. And so since there's two hydrogens, we put the subscript of 2. This, by the way, is carbonic acid. And carbonic acid, you may recall from last week's topic, is a very weak acid that falls apart and undergoes an additional chemical reaction, a decomposition reaction, releasing carbon dioxide gas as a gas, and water is left behind. But you may recall that from last week. So once again, here is the chemical equation we just talked about between the sodium bicarbonate and the acetic acid, an example of a double replacement reaction. And so what I'd like you to do now in your books is write this reaction down and then go through the 4 steps of balancing the equation. When you have finished balancing the equation, I'd like you to do the rest of what I asked you to do yesterday. Go back to those 2 pages in last topics in the book of the last topic, and I'd like you now to identify the double replacement reactions on those 2 pages and balance those other equations as well. So by the end of the day today, you will have identified on pages 135 and 136 all of the chemical reactions as either synthesis, decomposition, single replacement, or double replacement reactions, and have correctly balanced them. So if there are any equations there that you had tried to balance last week and weren't able to do so, you have another opportunity today to practice balancing those equations a little bit more. So I'd like you to take your time today to complete that, and then I'll have some additional work for you to complete when you are finished. Tomorrow, we will begin 2 days of activities, a day of single replacement reactions and a day of double replacement reactions. And then, of course, on Friday will be our quiz. So until tomorrow, I'll say bye-bye.